Boa noite, meu nome é Melanie Betancourt e obrigada a todos por terem vindo. A razão desta pequena palestra é basicamente para introduzir finalmente a ThermoLignum Açores, apresentar os membros da nossa equipe, falar um pouco sobre o método para aqueles que ainda não estão familiarizados com ele, esclarecimento de dúvidas e preocupações e finalmente reunir contactos de alguém que possa estar interessado no tratamento. Começamos com o Orlando Carreiro, da Universidade dos Açores.
Boa noite a todos, eu agradeço antes de mais o convite feito pela Melanie e também a vossa presença e vou falar muito brevemente de como surgiu o contacto com a ThermoLignum e como começou o processo de, pelo menos o conhecimento acerca deste problema que temos das térmitas aqui em Angra do Heroísmo e agora infelizmente já sabemos que está em mais ilhas daqui do arquipélago. A térmita, descobrimos que tínhamos esta térmita em 2002 e pouco tempo depois, em 2004, por intervenção da Câmara Municipal e a pedido da Câmara Municipal, começámos a fazer os primeiros estudos e percebemos que a situação era bastante grave na cidade. Mais tarde percebemos que também, inicialmente com o financiamento da Câmara Municipal de Angra e mais tarde da Direção Regional da Ciência e Tecnologia, de que este problema não era só desta ilha, não só de Angra, mas de outras cidades e que, com a visita de vários entomólogos especialistas em pragas urbanas, que este problema era um problema que infelizmente estará cá, em Angra e Ponta Delgada, por exemplo, para ficar ao longo de várias gerações. Por iniciativa da Secretaria Regional do Ambiente, conseguimos trazer, na busca de soluções para resolver este problema, conseguimos trazer duas empresas que apresentavam soluções com temperatura, sem recurso a químicos, que seriam, na altura, também por aconselhamento de vários entomólogos que trabalham com pragas urbanas, a melhor forma de lidar com este problema. E foi nessa altura que contactámos a ThermoLignum e também uma outra empresa norte-americana, Thermopur, se não me falha a memória, e com uma avaliação e acompanhamento independente da Universidade e também do Laboratório Nacional de Engenharia Civil, conseguimos verificar que a ThermoLignum prestava um serviço e tinha uma eficácia muito maior de tratamento, não só porque ambas as empresas conseguiram matar as térmitas, que era o objetivo, mas em termos de conservação da madeira e para as condições que nós temos aqui específicas, de umidade, etc., revelou-se ser a empresa mais indicada para este problema que temos aqui, para o tipo de habitações que temos. Isso já foi há algum tempo, entretanto a ThermoLignum, através do Bernard, reatou aqui alguns contactos e por fim a Melanie e o Bernard conseguiram chegar à ThermoLignum Açores. Eu desejo a maior sorte e espero que gostem da apresentação que vai ser feita e que confiem neste método que eu tenho fé que seja bom.
Obrigada, Orlando. A ThermoLignum Açores é uma filial de uma empresa multinacional, ThermoLignum International. Hoje temos presente o Bernard Schackenhofer, da ThermoLignum Áustria, e o Nikolaus Wilk, da ThermoLignum Alemanha. A ThermoLignum Açores é representada pelo Orlando Carreiro, que acabou de falar, o nosso técnico, o diretor técnico, Vítor Brasil e Ângelo Carvalho, com formação em tratamento de edifícios, e eu, Melanie Betancourt, sócia-gerente, com formação em tratamento de objetos em câmara fixa. A ThermoLignum Açores foi criada em resposta à demanda por uma solução para um problema muito falado na nossa região, as térmitas. A técnica chamada Warm Air, utilizando umidade controlada, é uma forma ecológica para erradicar insetos que causam danos, como por exemplo a térmita, o caruncho, o besouro e a traça. Conseguimos erradicar de uma vasta gama de materiais orgânicos de diversos tamanhos e categorias. Daí vem o nosso slogan, From Art to Architecture, de arte à arquitetura. Ao longo do próximo ano, investimentos serão feitos serão feitos em várias abordagens de tratamento. Começando com uma câmara fixa, utilizando a técnica de warm air com umidade controlada para tratar objetos móveis feitos de materiais orgânicos, tais como mobílias, estofes, têxteis, cabedal, livros, obras de arte, quadros, esculturas policromadas e taxidermia. Equipamentos para tratamento de tetos simples, utilizando somente a técnica de warm air, também fará parte do investimento inicial. Durante o ano 2015, o último investimento previsto será feito no equipamento de tratamento de edifícios utilizando a técnica de warm air com umidade e a técnica de wrap ou envolvimento. Este equipamento será ideal para tratar edifícios decorados, bem como objetos sensíveis no próprio local, como por exemplo altares, órgãos, sobrados, tetos pintados e outras estruturas de elevado valor patrimonial. A ThermoLignum é uma alternativa ecológica, finalmente ao seu dispor, que não utiliza produtos químicos, não deixa resíduos ou odores nocivos, garante 100% de mortalidade e é um processo rápido, sensível e não invasivo. Este processo permite o uso imediato do objeto ou área tratada, que se torna as vantagens claras. Agora passo a palavra ao meu colega, Nicolas Wilk, da ThermoLignum, Alemanha.
Hi, my name is Nicolas Wilke, and as Melanie has said, I work for ThermoLignum. I work in Germany. I'm sorry I don't speak Portuguese, but I'm confident, and I heard that you all speak English or understand English. I'm a conservator, that's my job. I've been conserving and restoring furniture, polychrome sculpture and paintings for the past about 25 years. And this is how I got in contact with this company, because we consider this process as an integral part of conservation, as you can see in the brochure, which is back there. By the way, before I forget, we have here not very many, but a few CDs with English and German and I think even Japanese scientific studies. So if any one of you wants to go into the depth and scientific aspects, there's also a study, for example, whether this process changes the DNA in natural history specimens. So it's if you're interested, take one. If you're not interested, don't take one, because we don't have very many. It's very important to realize that there are different types of treatment. This is also very important with respect to the costs of the treatment. And I will try to explain that to you. This is what ThermoLignum originally started off with. In the beginning, they treated furniture, but then it went on to treating polychrome sculpture, paintings, picture frames, and it resulted in really treating all organic materials which are present in modern and nowadays museums. And there isn't really any material we can think of which we can't treat organic materials. And these high quality works of art need a very, very finely tuned treatment cycle and a very carefully controlled, humidified atmosphere inside the chamber where we treat it. So this is like the high-end sort of treatment. When it comes to buildings, we have buildings which we treat with added humidity in the hot airflow, but that is not always necessary. And the second version is treating very simple building constructions, for example, the truss of a roof, where you just have constructional rough timber. And that you can easily treat with just warm air jetting into the building. And even though you might get, or if you have a beam like this, if you just get tiny cracks, or if the cracks which are in there anyway, if they get a little bit bigger, and after 6 weeks they'll go back. That doesn't really matter. So it would be an overkill to treat a very simple roof construction with controlled humidification, especially with respect to cost. So we have to think first, what's the object we're talking about? And we have to adapt the treatment to the object. Is it a pile of raw wood construction beams, or is it an exquisitely painted ceiling or a gilded sculpture? You will see some pictures of that later. So this is what I want you just to keep in mind as this talk goes on. The idea behind it, every insect dies at a certain temperature if this temperature is held for a certain period of time. And there are just 2 examples here for 2 wood-boring insects, and it shows how much time is needed to have them killed. Drywood termites, which is quite, it's quite good actually, they already die at 49 degrees centigrade. Some wood-boring insects need up to 55 degrees, and that's a considerable difference when it comes to the length of the treatment. So, in order to kill an insect, you warm up the object. Now, obviously, especially for me as a conservator, but you will know that too, if you warm up an object, it loses humidity, it shrinks, and it might cause cracks. And you don't want that to happen, especially in sensitive objects of art. And this is so one of the concerns you might have is dimensional changes in the object. There's another factor which might cause damage in the object, and that is an excessive temperature difference between the surface of an object and the core. So if you heat the object up too quickly, that difference will be very, very large, and you don't want that to happen. And there's this, the keyword diagram, it's really the foundation of our principle. And even though we don't follow his curves exactly, because they go up to steep, but that I won't go into that. We've sort of optimized this curve, this function, to our purpose. And it shows the correlation between temperature, relative humidity in a room, and the actual moisture content in the object. And if we warm up an object, what we try to aim at is not to change the equilibrium moisture content of the object. So if we warm up a room, and this table has, 20 degrees, and we warm up the room to 55 degrees, we don't want the moisture content in this table to change. So what we have to do is humidify the air during the process, like pump in water in the form of steam. So the humidity content in this room rises, and there's no exchange of humidity between the table and the surrounding air. And when it cools down again, we take away moisture from the air. You will see that in a diagram later. And this shows the correlation of how much water you have to add to the air when you rise the temperature. I was talking about the difference between the surface temperature and the core temperature, which we call the delta T. And you can see that here. And you want that to be not too large, this difference. But we can set it with our computers. This, by the way, applies to the high-end treatment, which I mentioned, for really sensitive objects of art. This is not necessary for all building treatments. For some building treatments, it is necessary, but only for very few. I'll get to that later. So we measure the core temperature, we define the temperature difference, and we control the chamber temperature, the room temperature. This is what a chamber looks like for sensitive objects of art, and this is the chamber which several museums in Europe have been using for the past 10 or more years. I think there are 3 chambers now. There will be 5 eventually in the country of Norway alone. The University Museum in Norway has one of these, and they treat everything they get into their depot nothing enters the depot without having been through our chamber now. And until now, they must have treated around 28,000 objects in this chamber, all different sorts of objects. Now, we had this temperature sensitivity of insects, and we have the delta T, which we define, and we have the correlation, moisture content of the object in the air. And if you pull this together, you come up with this. This is a typical chamber run for us. And there's another, yes. And obviously, we start at temperature at 0.0, not temperature, but 0.0 of the treatment cycle. And we have the warming phase, and we slowly warm up the temperature in either a building, when we do a building treatment, or inside the chamber, when we do a chamber treatment. This blue line shows the relative humidity, which is always constantly being monitored with a sensor, and the result of the measurement is fed into the computer, which adapts it. And we have the room temperature in a building, or the chamber temperature, which is the red line, and we have the yellow line, which is the core temperature. They're constantly monitored. Then we have a holding phase, which obviously we set to a temperature where we know that the concerned insect will die. So in the case of a termite, I said they die at 48 to 49. We would probably set it to 51 or 52 just to have a safety buffer. Okay. So you have the holding phase, and then again you have the cooling phase. And you notice that the moisture curve is not, as some of you might expect, an absolutely straight line, because we always say, you know, we keep the moisture content of the air and we keep it constant. But that does not mean that it's a flat line, because as we saw from the Kylewood diagram, it's not a linear function. So there's a certain hump to it. And this makes it impossible for moisture in the object to exchange, which is what we want. So I want you to think again, what I've just talked about is sensitive art. It's not necessarily in buildings. Just keep that in mind. So here's a typical chamber. It's just a scheme. You have the air is sucked in on top, and the air flows in at the bottom, humidified air. We have 4 temperature sensors in the corners. There's 2 on the top, in the back on the back wall, and there's 2 on the bottom, on the front, on the side walls. And we have a dummy with a temperature sensor in it. Obviously, if we have a sculpture, we don't drill into the sculpture and put a sensor in there. So we have various sizes of sensors, from quite small to very large. And the diameter of this dummy corresponds with the maximum diameter of an object which we have in there. So we know that once the temperature has been reached in the dummy, it will have reached the same temperature in the largest diameter of the pieces in there. So it's really quite straightforward. And I'll just give you some examples of furniture of pieces which have actually been and these pieces were in our London chamber, some from museums and others from private collectors. These are gilded sculptures holding this tabletop. There's actually a bit which goes on top, but this is just to demonstrate that you can actually mix various materials. Then we have these pieces, which we have a branch in Belgium very soon, and we did some test runs for Brussels museums. The left one was from a church in near Antwerpen, and the right one is a triptych dated 1633, and it's a very, very valuable piece. And in fact, the conditions of this piece, of the altarpiece you see on the right, was absolutely meticulous. There was not a spot. And the middle painting had been restored at some point, but the 2 outer paintings. It's oil on wood, so it's a panel painting. And before and after the treatment, there were no changes at all, and that it had never been restored, and it's just absolutely perfect conditions, and it was in the same perfect conditions once we got it out. Just some more examples. The right one is a canvas painting. We've actually treated a painting by Sandro Botticelli in the London Chamber, and that's quite some years ago. Some London conservation studios used to do freezing or low oxygen treatment, but they came to realize that it's not necessary, and they're really, almost all of them are working with ThermoLignum now. They were very reluctant in the beginning because they thought, high temperature, etc., and it might damage the object, but it does not. It definitely doesn't. This was quite a big thing we did for the Natural History Museum in London. They had thousands of entomological drawers and other natural history specimens which they needed to treat, or at least they were trying to find out ways to treat objects. And they calculated that if they did the amount of objects they have, if they treated these with low oxygen, which is a fine way of treating some objects, but it would have taken them something like 36 years. So they thought, we're not going to do it with low oxygen, because it's just, it's a nightmare, it's a logistical nightmare, because every treatment cycle takes about 8 weeks. Some other pieces we've done for the Victoria and Albert Museum. Hey, this is automatic. It's the Great Bear of Ware, which was returned to Ware, and it was in the V&A for I think 30 years or something, and it went back recently, and we treated parts of it, and the famous lip sofa and some Yamamoto costumes. And moths are an increasing problem in museums, ever more. So we treat a lot of textiles now. And that brings me to the next option, to the next method we can use. If you can't move an object, for example, an altarpiece in a church, if you can't dismantle it, we build a chamber around the object and take a mobile processor and all the electronics and treat it in situ. Treat it where it is. There are limits to this. We cannot treat an altar which is fixed to a wall. If we can't get behind it, you will get condensation water problems, because you have the warm air and you have the cold outer wall, and you will have water running down the back. And obviously the water, in most cases, you don't want water to get in touch with the substance of the piece of art. So, but in some cases we can treat it. Just two more detailed pictures. There was a scaffolding around the altar, and there's some special insulation foil we use for this. We wrap it up, we seal it very carefully, and there's the mobile unit and the electronics control panel and the PC. And this treatment we did, I think it was March, wasn't it? I think it was in March.
January or February.
Or February even. And it took, the treatment itself was about 24 hours. It took us a few days because we treated 2 large confession chairs in the same church. Obviously it took some days to erect the scaffolding and put the foil around it. But it's a fairly quick job. And now let's come to building treatments, which is probably your main concern. And I mentioned before that there are 3 different types, really. The simplest one is for simple constructions, for roof trusses, where you just have raw wooden beams of no historical value. They're just there, to hold the roof in place. And you can easily treat a situation like that with just blowing warm air into the attic, in this case, into the truss. You will have temperatures of around 80 to 90 degrees. Obviously, the humidity, the relative humidity, drops down to almost zero, which will result in one or the other crack in the beams. But in this particular case, it doesn't matter. We can do the same treatment. We can also kill the bugs with humidification. But as I said, it's an overkill, and it would cost a lot more. So just remember, what sort of objects are we talking about? Is it necessary? So here's, this was taken in the Azores. I believe Bernard took this picture. That's a typical situation where we would say you don't need humidification for that. One or the other gap, or the floorboards you can see on top, they might, because they shrink, they might just open a little bit, and you might have some gaps in between the floorboards. And those gaps will, at some point, after some weeks, after they've taken up some moisture again, because it's quite humid here anyway, they will close again. You might find a few remaining gaps, but in this case, this is justified. Another situation where we would think that you can treat this without humidification, because there's nothing you really have to worry about. And there's the next option is treating buildings of historical or artistic value with added humidity. You add water steam into the airflow. You don't really control it as finely as we do in the chamber, but still you can get the relative humidity inside a confined building or confined tent. You can level it out to maybe between 15 and 20%, which is a lot less than it is over here, but it makes a huge difference whether you have 2% or 15%. It makes all the difference. So it is very unlikely that you will find any cracks after a treatment, even though you only have the relative humidity at, say, 15% or 20%. And it's also important to know that if you humidify the air, the energy content of humidified air, when you warm it up, is much higher than that of dried air. So usually the process is also quicker. Here's an example of, some of you might have seen that a building was treated. Was that, Bernard?
We treated it in 2010.
Okay, so these pictures were taken in advance, I think.
Yeah, that was
and
the first we did.
Obviously, you see here that this is not as rough as the pictures we've seen before. There's probably some, I don't know if this is, what's the word, rock sheet? Sheetrock. Sheetrock, or whether it's wood paneling, but obviously there's some more sensitive objects in there, and the floor also looks a lot better than in the other dilapidated buildings you've seen before. So you want to be more careful here. And so we add water steam into the airflow, and the room has to be emptied if you treat it. So they took out the furniture. Here you see some temperature sensors lying around, and the next picture will show you actually which building it was in your beautiful city. And what is this? I'm not. So you see the air hose with the warm air coming out, with one end blowing this side and the other one blowing there, and on the outside of the building, all going up. And again, you see loads of temperature sensors on the bottom, and actually some live termites in those wooden blocks. They're for controlling, obviously. See if they're dead after the treatment. Yeah, this is just to show that this doesn't necessarily mean that this is a job without humidification, because if you look at what's underneath, obviously this needs extremely careful treatment. You could never do this with just dry air. This is a combination of an in-situ treatment, like you've seen with the altarpiece, which you wrapped up. So this would have to be sealed off, and the bottom side of this would have to be very, very carefully controlled with the mobile processor, so that the relative humidity we probably have to treat this with about 55%, so that there are no changes in this painted ceiling and in all the stucco around it. And just because it was so pretty, I want to show you that we were ordered to Japan in May, because they have huge problems in one of their historical temple sites called Nikko, and they don't know how to cope with it, because these are not termites, these are woodworm. So, but it was a very, very impressive visit, and we're still working with scientists from Tokyo and Kyoto University if we can help them. That's it.